Good morning, students. Previous video was not clear, it seems, so I am repeating the topic once again, not completely, from the circular motion onwards. In this part, system of particles and rotational motion, 7th topic, first we have covered first part of this same topic, center of mass. Next part is circular motion and rotational dynamics together we take. In this circular motion, we take the object moving around a fixed point. In the case of circular motion, object moves around a fixed point at a fixed distance. The distance from the center of the distance from which about the fixed point the object is rotating is called as a radius. And for circular motion, the radius value remains constant. Radius is taken as a vector. It is always directed away from the center of the circular path. And velocity of the particle at any instant is along the tangent to the circular path. And imaginary line passing through the center of the circle and perpendicular plane of rotation. This is a plane of rotation on the plane, on the imaginary surface the object is rotating. The imaginary line, it is not a fixed value, we just take the imaginary line passing through the center of the circle and perpendicular plane of rotation is called as an axis. If you see from angle side, you will see the center like this. This is going to be the axis of rotation. This is a particle m of having mass m, velocity is v. The distance from the axis of rotation to the particle when rotating, that is nothing but called as a radius. The radius value remains constant for the circular motion. But rotatory motion means rotation motion need not be circular motion. If you take the planets revolving around the sun in the elliptical orbit, sun is at one of the foci points of the ellipse and planet's distance from the sun is not constant. When the planet is, this for example earth is far away from the sun, it is called as a apogee. It is also called as aphelion. Helio means a sun name. Farthest distance from the sun is called as a apogee or aphelion. The distance is going to be RE we can take. And the shortest distance from the sun is called as a perigee. Perigee or perigee, it is called as a perihelion. From the foci point to the extreme ends, the maximum distance and the minimum distance for the elliptical paths are called as a perigees and apogees. For the helio means sun, specifically we have the aphelion and perihelion. Okay, that names are not important right now in this case. You will be learning that those names in the gravitation topic, whatever. This is also a rotational motion, but here the distance from the sun to the planet is not constant. It is a rotational motion, but in the case of circular motion, the distance from center to the object remains constant, and radius vector, wherever you take, whatever the shape you take, the radius vector is always the displacement vector. It is directed from the center to the object which is in rotation. Here it is a center point, for this is not a center point, and in that case, to apply comparison with these circular motion, now we take the average radius. Average radius is nothing but equal to perihelion distance plus aphelion distance by 2. That is the average radius we take and compare with the circular motion. Next, the object moving from one point to other point within the circular path, then the radius vector rotated by some angle, say theta. The theta is called as an angular displacement. It is nothing but angle only, but term we call it as an angular displacement. Angular displacement theta. It is the angle of rotation of radius. You can call it as radius or radius vector. It is the angle of rotation of radius vector of object or for object moving in circular path. It is the angle of rotation of radius vector of the object moving in circular path. This is the center of the circle is O. R bar is the radius vector, velocity is like this. Ready? Same thing we see from the side view. Axis, r bar, velocity. The radius rotated by angle theta, and this is going to be arc length. Take it as a s bar or s. We take it. This is the distance traveled from A to B when the particle moves. At velocity is a vector. It is directed along the tangent to the circular path. You have to take always. So radius is rotated from by angle theta in the time t seconds. The time taken is t seconds when the object is traveling from point A to point B. The velocity is a vector and is directed along the tangent to the circular path. So direction keeps on changing. When the particle is here, the tangent is in the direction. Afterwards, the particle is here, tangent in the direction. Particle is here, tangent in the directions. In the direction of rotation, you take the arrow mark. So velocity direction keeps on changing. So what we consider the velocity is the instantaneous velocity. The value of the magnitude of the velocity, we take it as a speed. The speed value may be constant, may not be constant. Direction compulsory changes when the object is moving in a curved path or in the circular path. The angle of rotation itself is called as a angular displacement. The SI unit of angular displacement is radians. And from the geometry we know that theta is equals to arc length s by radius r. Theta is equal to s by r. S is also a length distance only, r is also distance, not a displacement. Please, displacement we can consider s as a displacement. That is the shortest distance between A and B is the displacement, provided theta is very less. If you consider very small angles, if you consider this curve is almost straight line we can take, then distance becomes equal to displacement. SI unit of this angular displacement is radian, R-A-D-I-A-N, radian. In short we call it as a rad, R-A-D, rad. Other units what we take is degrees also we can take. One rotation, if the object moves in a complete one rotation, then the distance s becomes equal to 2 pi r. From the diagram what we can take is for circle, theta is equals to arc length by radius of a circle. This angular displacement theta equal to arc length, that is s, by radius of circle. I have taken the smaller or capital R we can take, that is left to it. That means theta is equals to s by r in terms of radians units. S is also meters, this is also distance, this is also distance. Meter by meter units will be cancelled, but we take the units for this S unit separately given for understanding purpose, that is called as a radians. If you take for one rotation, for one theta is equals to one rotation or one revolution. One rotation or one revolution, the theta value, s becomes equal to complete circumlength, that is 2 pi r we take it. S equals to 2 pi r, circumference of circle or circumlength r we can take of circle. Therefore, we have the formula for theta as s by r, but s becomes equal to 2 pi r by r in terms of the radians. That means for one rotation theta becomes equal to 2 pi radians. Therefore, theta value is equals to one rotation is equals to one revolution. Also we can take rotation revolution difference is what? If you take the Earth is rotating about its own axis along the north and south poles. It is spinning about its own axis. We call it as rotation. Earth is also revolving around the sun in elliptical orbits. Rotating around the other object is called as a revolution. But in both the cases, radius vector rotation only we are considering. Such cases we take the theta is equals to one rotation and one revolution, same relation, that is equals to 2 pi r. By r means 2 pi radians remains. So theta equal to one rotation or one revolution. E is equals to 2 pi radians. For one rotation, what the angle, practical units what we take for the angles is degrees. So it is also equal to 360 degrees. You must be able to convert 1 radian equal to how many degrees and 1 degree equal to how many radians. This is important required for conversion of the units while doing the problems. mainly required is degrees to radians terms. 2 pi radians equal to 360 degrees. So 1 radian equal to 360 by 2 pi in terms of degrees. This is going to be 180 by pi degrees. Pi is 3.14 in terms of degrees. We can write degree symbol, circle on the top. Superscript or DEJ also we can write. Degrees, approximately dash degrees you take. 57 degrees something you will get, you check up that. Next is 1 degree equal to 2 pi. This is a 360 degrees means 360 into 1 degree. 2 pi radians means 2 pi into 1 radian. So 1 radian becomes equal to 2 pi, go to the right side here. Similarly 360 degrees means 360 into 1 degree. So 1 degree means what? 360 go to the left side. 2 pi by 360 it becomes. 2 pi by 360 in terms of radians, which is pi by 180 radians. This is equals to dash radians in the fractions, you check up that. I am leaving these 2 points to you, or else I am going to revise this, will be repeated again in the topic units and measurements. Angular velocity. It is the rate of change of angular displacement with time, or you can simply say that angular displacement per second is also called as a angular velocity. Angular displacement per second for rotating objects is called as angular velocity. Angular displacement per second for rotating object is called as angular velocity. The symbol we take is omega. It is not a W, please. Omega symbol is different. This is omega, this is W. Or small w also we can take is this, all equal heights we take. And capital omega is this. This is units of resistance we use ohm. This omega symbol we generally use it for the angular velocity, small letters of the Greek letters, omega. Angular displacement per second for rotating object is called as a angular velocity. Writing this rotating object is not compulsory. When you ask for the definition, you just know that angular displacement per second is enough. It is called as a angular velocity. That means this omega is nothing but equal to angular displacement theta by t, where theta is angular displacement in time t. Theta, from A to B object moved, velocity everywhere is along the tangent to the path, and this distance travelled is arc length is equals to s, moving in this direction, and radius vector rotated by angle theta. Then what is the angle rotated in the time t seconds? The time is the t seconds travelled. This is the time t equal to 0, t1 equal to 0, this t2 equal to t we take. After t seconds, particles should be. So we can also take that in case if the two different angles given means we can take as the theta 2 minus theta 1 also we can take. The angular displacement is radians, pi time is nothing but radian per second is the SI unit we can take. We can also take the other relation is theta is equals to, we have the relationship theta is equals to S by R. We will take the relation, that thing later. Angular velocity is vector, so it must have direction. It is directed along the axis of rotation. It is directed along the axis of rotation. This point is important for us. Units, SI unit we can write is the radian per second. SI unit is of omega is radian per second. Dimensional formula. Theta don't have dimensions. Theta is nothing but equal to arc length by radius. Dimensions or dimensional formula gives the relation between the fundamental quantities and derived quantities. Theta is the angle derived from the two values S and R, but whereas the length, mass and time, they are called as fundamental, they do not depend on other physical quantities. But angle depends on the other physical quantities like S and R, so these are called as the derived quantities, derived from other physical quantities. But S is nothing but a length only, R is also, radius also length only basically. So this is nothing but equal to L by L, cancels. What you get is L to the power of 0 and M to the power of 0, T to the power of 0. L is the dimensional symbol for length, M is for mass, capital letters we have to take, and T is time. These terms we again will be getting in another topic, units and measurements. Length, mass and time. The powers of these basic quantities, length, mass and time do not depend on other physical quantities, they are called fundamental quantities. The powers of the fundamental quantities are called the dimensions. Here this 0 is the dimension of time, mass dimension is 0, length dimension is also 0 in the angle theta. L to anything power of 0 is 1 only, that means this whole thing is equals to 1, that means theta don't have dimensions. Don't have dimensions means powers are not there, powers we take it as a 0 for the fundamental quantities, length, mass and time, and other physical quantities like current also, but here they do not depend on that. So theta don't have dimensions, but time has dimensions. Time is nothing but t only, but t is coming in the denominator. So what you get the dimension formula is, this is m0, l0, t0 means 1 by t means t minus 1. Omega, this square brackets we write indicating OF of, dimensions of, meaning, which is equals to m0, l0, t0 by t. T take it to the numerator, t minus 1. It becomes equal to m0, l0, t minus 1. Just simply 1 by t we can write, just t minus 1 also we can write. This also we can be written as equal to just t minus 1, because m to the power of 0 is 1, l to the power of 0 is 1, we can write t minus 1. Dimension formula of the omega is t minus 1. What do you mean by axis of rotation is, if you see from the different angle for the rotating object, this is the radius vector, velocity, this is the direction of omega. This is axis of rotation. So when particle is rotating, this axis, object is rotating around it, velocity is along the tangent, and omega is along the axis of rotation. How do you find this direction? Omega is with the help of right hand thumb rule. Curling fingers you take in the direction of rotation of the object, thumb will be in the direction of omega if you keep right hand on the plane of rotation. Like a fan, if you take the blades are rotating with some speed, that speed is, rotation speed is called as a angular velocity, or angular velocity is the taken with the symbol omega and direct along the axis of rotation. Angular speed, if you use the term, that is the magnitude of the angular velocity is called as angular speed, but angular velocity is a vector. Angular speed is the magnitude of the angular velocity, that is taken as a scalar quantities. But if you take one rotation, if you take for one rotation, theta becomes equal to 2 periodians by t. The time taken for one rotation is called as the time period. Time taken for one rotation is called as the time period. Therefore, one rotation omega becomes equal to 2 pi by capital T. That is the time period it becomes. That we will check up what is the term called as. For one rotation or revolution you can take. For one rotation, theta equal to 2 pi radians. And t becomes equal to capital T, called as a time period. Therefore, what happened to this omega? Angular velocity omega is equals to theta by t becomes equal to, theta is 2 pi radians, this becomes equal to 2 pi by capital T radians by time is radian per second. So we can write this omega is also equal to 2 pi by t. And 1 by time period is called as a frequency. Frequency f, better write as f is equals to 1 by time period is called as a number of revolutions per second. Per second, revolutions or rotations. You can write here rotation, number of rotations per second. Units will be per second, we can take 1 by second, or hertz also we can take the units for this frequency, number of rotations per second. Whereas the time period t is the time taken for one rotation, for one rotation. T is the time taken for one rotation, whereas the frequency is number of rotations per second. Both are interrelated as inversely related. Frequency is inversely proportional to time period. This relation you need to know. And frequency symbol generally you will be given as a nu symbol, not f generally. F may be also given. Nu is a symbol used for the frequency also, but I am not writing nu because we are going to use the term velocity v. V and nu look similar even while printing also. That's why I am avoiding that. I am using the symbol f. But use the symbol what is given in the examination, the question paper what symbol give, that only you have to use for it. When you are using this times in terms of the frequency, so 1 by time period is a frequency, therefore we can write this omega relation as theta by t. We can write for one rotation if you have taken, that is also becomes equal to 2 pi by t. 1 by time period is frequency, therefore we can also write the expression as 2 pi f. Omega has a different names. Revolution already we have taken in terms of the angular velocity, but magnitude of the angular velocity is called as a angular speed. If you are using in terms of the f frequency, it is also called as the angular frequency. Angular velocity, same omega only, comma, angular frequency or scalar quantities, or just write the scalar terms, better write this, or magnitudes we can write, or magnitudes of angular velocity. They are scalar. Velocity is a vector. Velocity magnitude means value only. We can also call it as a speed. That is a scalar quantity. So angular velocity, if we are using the velocity, means that is supposed to be a vector. Angular frequency, angular speed, angular speed omega, no bars. Angular speed omega and angular frequency. Angular speed, angular frequency are taken as the magnitudes of the angular velocity. This is the omega bar. All are omega symbols only. Angular velocity symbol we take it as a omega only, but bar vectors from we can write if you are mentioning as a vector equations. So these two are called as a scalars, but angular velocity is a vector. Once again, angular speed, angular frequency are magnitudes of angular velocity. They are scalar quantities. Next is relation between speed or linear velocity v, or you can call it as the speed terms also. Speed of rotation v, angular speed omega, comma, radius of circle. Or relation between speed of rotation, it's the magnitude of the velocity you are taking, angular speed omega, speed of rotation is v, and radius of circle is r. Radius is circle is r, vector directed away from the center. Velocity is a vector along the tangent. Magnitude of that velocity is the speed we are taking. Angular velocity is also a vector directly along the axis of rotation, but we are considering here only the magnitude. At the end we discuss the vector relationship. What is the relation between theta and Sra? S is theta is equals to angular displacement. So I will use the black pen. Theta equal to S by R. Dividing with time, what you get is, or differentiation we can take up. Differentiating with time, or divide with t. The displacement of theta is taking place in the time t seconds. That we can take both sides, dividing with time t, both sides of the equation. What you get the relation is theta by t is equals to s by t into 1 by r. Theta by t is nothing but omega. Omega equal to v by r, or v equal to omega r, where v equal to s by r, s by t, that is a distance travelled by time, is a speed, and theta is equals to, so omega is equals to theta by t, angular speed. Angular speed. And what is S here? S is arc length, and theta is angular displacement in time t. Instead of this by t, we can take the differential form, means d theta by dt also we can take this, ds by dt also we can take for the ds. Dt also indicates for the small angles or small values, or also taken as a different in values also. And what is this relation in vector form? Is taken as v bar equal to omega cross r. We take cross product we take because all the three are the vectors only. Velocity is also vector at the given instant of time, and omega is also vector, r is also vector. So we take there is a cross product between the v omega r, and the angle between them is v is along the tangent. Tangent is always perpendicular to radius. This is 90 degrees, and omega is perpendicular to the radius. So this is also 90 degrees. All are perpendicular to each other. So v omega are perpendicular to each other. We have to take. Vector relation is v equal to omega cross r. We have to take. Now if we take the bar, means we take it as a v is a velocity, omega is the angular velocity, r is a radius vector. We take it v comma omega r are perpendicular to each, means angle between them is 90 degrees. So if you take the cross product magnitude, no, v equal to omega r sin theta we have to get. When you get the v omega r sin theta,